In this video, let's see how to interface analog to digital converter chip with 8085 microprocessor. For that, let's consider a popular or commonly used ADC, namely ADC-0808 or 0809. Analog to digital converter, that is ADC, is an input device which converts analog voltage to digital value. ADC-0808 is an 8-bit ADC with 8 multiplexed input channels which are selected by address lines A, B and C. It is highly versatile device and it is found in wide range of application like data acquisition system, MUPI based instrumentation system, control, etc. It operates on plus 5 volt supply and the input range is 0 to 5 volt and its operation is based on successive approximation technique with typical conversion time of 100 microsecond with less power consumption. So as mentioned above, it contains 8 multiplexed input channels in 0 to in 7. So these are analog inputs. So in order to select these channels, we need a channel selection address that is provided by A, B and C pins. So first of all, in order to operate this one, we need to connect analog signal to the required channel. Then it is required to provide channel selection signal or address required for the desired channel through these pins A, B and C. Then after 50 nanosecond, the ALE signal is made high. Then after another 2.5 microsecond, start of conversion, that is SOC line is made high and then low, that is SOC pulse is to be given into ADC using these pins. When this SOC start of conversion signal is reached on ADC, ADC will start the process of converting analog signal into digital signal. Then after completing this conversion, ADC will provide an active high signal, namely EOC. So when EOC signal goes high, it indicates that the digital signal corresponding to the given analog signal is available at the output pin of ADC, that is D0 to D7, so that data can be read from output pin of ADC. So ADC-0808 is an 8-bit ADC. It works on plus 5 volt DC. It contains 8 multiplexed input channel in 0 to in 7. This is the corresponding address which is needed to give to these pins A, B and C. If entire thing is 0, channel 0 is selected. This is corresponding to channel 1. And finally, this is the address corresponding to channel 7. Then SOC signal is required to start the conversion, analog to digital conversion. Then after completing the conversion process, ADC will send an output signal from ADC, that is known as end of conversion. It indicates that my conversion process is completed. So this is the basic operation of this ADC, that is ADC-0808. This ADC can be interfaced with 8085 microprocessor using programmable peripheral interface 8255. Here, in order to select multiplexed channel, say channel 0 we are going to select. Here, in order to select multiplexed channel, channel selection signals are required. It is provided by port C lower signal PC0 to PC2 like this. PC0 will give A signal, PC1 will give B signal and PC2 will give C signal. So that PC0 to PC2 will give channel selection signals. So from port C lower, only pending pin is PC3. It is used for giving SOC signal, start of conversion signal. Let's assume we are going to connect the analog signal to channel 0. So address is 000. For starting digital conversion of analog signal connected in channel 0, it requires an SOC pulse. That is, initially SOC will go high, then go low, so that it will look like a pulse. For that, PC3 should be initially made 1 and later it need to reset to 0. So when we are considering PC lower, that is PC0 to PC3, all these pins are used for giving signal into channel, that is into ADC. So PC0 to PC2 is giving signal for selecting channel and PC3 is used for giving SOC signal. So PC lower should be output port under this case. As end of conversion signal need to read through one port of 8255 in order to read the converted digital signal corresponding to the given analog signal into microprocessor. So end of conversion signal need to continuously monitor in order to take proper decision. So this can be readed by means of port C upper. Say it is connected to 7th pin of port C. So port C upper is input port. Then whenever end of conversion signal is high, it indicates that ADC conversion is completed, digital value is available. That digital value we need to take into new P through 8255. For that, one port is required. That is again input port. Let's take port A as the input port in order to read the digital signal from output of ADC into microprocessor through 8255. Another port is not required. Let's take that port as output port. That is port B is not required. Let it be output port. Now port A is input port. Port C upper is input port. Port B is output port. Port C lower is output port. In order to make this one, we need to write control word format. This is the control word format. Here mode of operation is IO, so it is 1. Then mode of port A is decided by these 2 bits. It is 00, mode 0. Then port A is input port, so it is 1. Port C upper is input port, so it is 1. Mode of port B is mode 0, so it is 0. Port B is output port, so it is 0. Mode of port C lower is output port, so it is 0. When we are converting these into hexa, this is 9 and this is 8. So corresponding control word format is 98H. And in order to make the ports like this, the instruction required is, first of all, we need to move this data into accumulator by means of this instruction. Then out that number, that is 98H, we need to load into control word register by means of this instruction. Whenever this instruction is executed, content of accumulator is loaded into control word register. After execution of this instruction, port A become input port, port C upper become input port, port B become output port, and port C lower become output port. Now let's see how to provide SOC pulse using 8255. PC3 make initially high, then low. Let's consider channel 0 as mentioned earlier. So how to make PC3 high? By putting 1. Initially the value of PC3 is 1. As we are considering channel 0, these values are 0. This is connected to A, this is connected to B, and this is connected to C of these address pins of ADC-0808. So this is the LSB nibble corresponding to port C under this situation. So how to provide this by means of 8085 instruction? This number is 8. So let's consider MSP nibble of the 8-bit number as 0. That number we can load into accumulator, and port address corresponding to port C is 02. That number 08 we can load into port C by means of out02 instruction. After this instruction, again we need to make PC3 0. Finally, PC3 0, there is no change for this channel. We are using channel 0 itself. So here it is equivalent to giving a pulse 1, 0. So under that condition, an SOC signal, actually SOC pulse is reached at the input of start, which is shown in pin details of ADC-0808 ADC. Whenever this type of pulse is reaches, it will start the conversion process. Then we need to check only the status of EOC, whether end of conversion completed or not. How to do this one? Again, MVA A,00 out 02. So by means of these two programs, we can create a SOC signal or SOC pulse. So when SOC pulse is reached at the input pin start, ADC start this conversion, that is analog to digital conversion process. Then we need to check the status of end of conversion signal. That is, we need to check whether conversion completed or not by monitoring end of conversion signal. In order to read this signal, we can use PC7 pin of port C. If end of conversion signal is high, PC7 become high. As mu P is reading this signal will be there in accumulator. So by rotate left instruction, we can check whether this 7 bit is 1 or 0. That is, we can check the status of end of conversion signal is reached high or low. This checking process need to repeat until end of conversion signal become high. That can be done by means of this instruction. This instruction take end of conversion signal into accumulator. Then if we are rotating that one, carry status becomes 7th bit. If carry is not there, it indicates that the conversion process is not completed. That is, end of conversion signal is 0. Now if carry is there, it indicates that the process is completed. If completed, we need to read the digital value through port A and save that into any location. For that, we can use this instruction. In 00, read the content of port A. So the content of port A is now the digital value that is loaded into accumulator by means of this instruction. Then that data, that is digital value which is available in accumulator, can be saved into location 3000H by means of this instruction. Finally, we can halt the program by means of halt instruction. And this is the complete program in order to do above task. So this is the interfacing circuit in order to do this particular task. So this is 8085 and related signal which is required in order to interface with 8255. This is the input signal which is connected to any of these channels from IN0 to IN7. PC3 is sending SOC signal as mentioned earlier, and ALE signal is also required for conversion process. And after completing this process, conversion process, ADC will provide end of conversion signal, active high end of conversion signal. Whenever this signal is high, we can transfer the data, that is digital data, through port A of 8255 into 8085 microprocessor.